As this year's crops continue to emerge, farmers may be thinking about applying nitrogen. We talked with UNL Extension soil scientist Charles Shapiro this week about how a mild winter and warm spring may make this year different.
The warm weather last fall and all through the winter gave us warmer than normal soil temperatures. And when the temperatures are warmer, there's probably more microbial activity, and so there would be more release of nutrients from the soil organic matter, previous residue from soybeans or corn. So there may be more nitrates in the soil than normal.
How does the moisture affect that, Charles, or the lack thereof?
Well, the microbes need moisture to live and metabolize and grow. So if the soils are really dry, and there are areas of the state that had very dry winters, so maybe the warm temperatures wouldn't be as important compared to where they were either irrigated in the fall or got normal winter precip.
Let's talk about testing for nitrogen before you apply it or don't apply it, and the PSNT test, the pre-sidedress nitrate test. Tell me a little bit about what this test is.
The pre-sidedress nitrate test has been around for maybe 20 years, and the idea of it is to capture the release from either manure, alfalfa, soybeans, any kind of end source that would be released during the warm May, April situation, and then using that number predict how much nitrogen to add. When farmers normally would take soil samples either last fall or during the winter, they don't know how much nitrogen is released during the spring. So the pre-sidedress nitrate test is done right before sidedress time, and so we have a more accurate number of what's in the soil, and then the farmer or the co-op or agronomist can choose their nitrogen rate based on the goal minus what's already there.
Are we talking about sampling every field? And so last year at the end of last year, we saw a lot of anhydrous application with great weather. So what's the sample size we're looking at?
Generally, we would like to capture sites that we think there would be mineralizable N, which would come from either soils with higher organic matter or where there might have been an alfalfa crop or manure applied. Generally, like on a sandy soil that's been in continuous corn, we probably won't pick up as much nitrate as some of those other ones. But given the fall year and winter that we've had, there may be more nitrates there. Now, to answer your question about fall application, if someone put anhydrous down in a band and they wanted to sample between the bands, if they had 30-inch bands and they took samples at 15 inches, they would probably get an idea of what the background N is. But given the warm fall, a lot of that anhydrous is already nitrate, so they would have to factor in the N they applied with the soil sample results.
After sampling and once you have that data, what do you do with the data? What are the different methods that you can use it in?
Well, this pre-sidedress nitrogen test is based on a 1-foot sample, 0 to 12 inches, and you'll get back a nitrate number. The university here in Nebraska uses the Iowa interpretation. We don't have our own, but essentially you are putting on about 8 pounds of N for each part per million of nitrate below about 23 parts per million. So if you go on the web, you can find their extension circular that goes in the details. But I think the important piece of information would be if your soil tests higher than 23, you don't need any nitrogen.
And what's the accuracy of the test?
Back about 15 years ago, there was a regional project that essentially looked at 300 different comparisons for the pre-sidedress nitrogen test, and they found 28 sites where the test was a failure. And most of those failures, 25 of them, the failures were that the pre-sidedress nitrogen test actually recommended too much nitrogen, and only 3 of them recommended too little. So that came out to about 28%, but most of those, that 28% was over recommendation. So we have pretty good confidence that if they come up with a high nitrate level at the end of May, early June sampling, that there's plenty of nitrogen there.